Hello everyone, I am Zahid Abbas. Welcome to my YouTube channel MATHCULUS. In this video we are going to learn about Cartesian Coordinate System in detail. Cartesian Coordinate System. Cartesian Coordinate System is a system which is used to describe the location of a point on a line, on a plane, or in a space region. Why Cartesian? Cartesian coordinates are called Cartesian because the idea was developed by the mathematician and philosopher René Descartes, who was also known as Cartesius. Cartesian coordinates system in one dimension. To describe the location of a point on a line, first we take a point anywhere on that line and use it as a reference point. We assign a coordinate 0 to this point and name it as the origin. The line runs or originates from this point in two directions. This line is divided in unit lengths by marking points on it. In one direction, the coordinates of the points are taken positive, and in the other direction they are taken negative. The line we get in this way is called as a number line. In the figure, the central point O is used as a reference point for describing the location of any other point. This point is called as the origin. The point 5 is 5 units away from the origin on the line in the positive direction. The point -3 is 3 units away from the origin in the negative direction. To describe the location of a point in one dimension or on a line, we need only a single coordinate. Distance between two points on a line. To find the distance between 2 points on a line, we subtract the absolute values of coordinates if both the points lie on the same side from the origin. For example, the distance between points 3 and 9 is absolute value of 9 minus absolute value of 3, which is 9 minus 3, that is 6 units. Similarly, distance between -4 and -8 is absolute value of -8 minus absolute value of -4, which is 8 minus 4, that is 4 units. But if the points lie on the opposite sides of the line from the origin, then the distance between them is obtained by adding the absolute values of coordinates of points. For example, distance between the point 5 and -4 is absolute value of 5 plus absolute value of -4, which is 5 plus 4, that is 9 units. Cartesian coordinates system in two dimensions. To describe the location of a point in two dimensions or on a plane, we take two perpendicular or orthogonal lines called axes as reference. These axes are two number lines that intersect one another at a point at right angle. That is why they are called perpendicular axes or rectangular axes. One of the axes is taken in horizontal direction called horizontal axis or x-axis. The other axis is taken in vertical direction called vertical axis or y-axis. The point of intersection of both the axes is called as the origin. Both the axes originate from the origin and run in both the positive and negative directions to infinity on the plane. Such a plane is known as a Cartesian plane. The rectangular axis divides the Cartesian plane in four infinite regions called quadrants. The word quadrant comes from quad meaning four. Starting from positive x-axis and moving anti-clockwise, first we encounter with first quadrant, then second quadrant, then third quadrant, and finally fourth quadrant. First quadrant. The infinite region bounded by positive x-axis and positive y-axis on the Cartesian plane is called as the first quadrant. If we take the angle in standard form, then first quadrant starts from 0 degree and ends at 90 degrees. Second quadrant. The infinite region bounded by negative x-axis and positive y-axis on the Cartesian plane is called as the second quadrant. If we take the angle in standard form, then second quadrant starts from 90 degrees and ends at 180 degrees. Third quadrant. The infinite region bounded by negative x-axis and negative y-axis on the Cartesian plane is called as the third quadrant. If we take the angle in standard form, then third quadrant starts from 180 degrees and ends at 270 degrees. Fourth quadrant. The infinite region bounded by positive x-axis and negative y-axis on the Cartesian plane is called as the fourth quadrant. If we take the angle in standard form, then fourth quadrant starts from 270 degrees and ends at 360 degrees. Location of a point on a plane. To describe the location of a point on a plane, first we determine its quadrant and then find its perpendicular distance from both the axes. The perpendicular distance of the point from the vertical axis is called as the x-coordinate of the point. It is also called as the abscissa. The perpendicular distance of the point from the horizontal axis is called as the y-coordinate of the point. It is also called as the ordinate. The x-coordinate and the y-coordinate are collectively called as the rectangular coordinates or the Cartesian coordinates. The coordinates are written in the form of order pairs. The order is important. First number in parentheses is the x-coordinate, and the second one is the y-coordinate. The rectangular coordinates of a point can be positive or negative depending upon the quadrant in which the point lies. As the first quadrant lies between positive x-axis and positive y-axis, so in first quadrant x-coordinate is positive and y-coordinate is also positive. As the second quadrant lies between negative x-axis and positive y-axis, so in second quadrant x-coordinate is negative but y coordinate is positive. As the third quadrant lies between negative x-axis and negative y-axis, so in third quadrant x coordinate is negative and y coordinate is also negative. As the fourth quadrant lies between positive x-axis and negative y-axis, so in fourth quadrant x coordinate is positive but y coordinate is negative. Note that x coordinates are positive on the right hand side from the y-axis and are negative on the left hand side. Similarly, note that y coordinates are positive above the x-axis and are negative below the x-axis. Let's try to learn how to define the coordinates of a point on the Cartesian plane. Consider this point. Draw a perpendicular line from this point on the x-axis. It meets the x-axis at 6. So x coordinate of this point is 6. Now draw another perpendicular line from this point on y-axis. It meets the y-axis at 5. So y coordinate of this point is 5. It means this point is 6 units away from the y-axis and is on the right hand side of the y-axis. This point is 5 units away from x-axis and it is above the x-axis. Consider this point. Draw a perpendicular line from this point on the x-axis. It meets the x-axis at -7. So x coordinate of this point is -7. Now draw another perpendicular line from this point on y-axis. It meets the y-axis at 6. So y coordinate of this point is 6. It means this point is 7 units away from the y-axis and is on the left hand side of the y-axis. This point is 6 units away from x-axis and it is above the x-axis. Consider this point. Draw a perpendicular line from this point on the x-axis. It meets the x-axis at -8. So x coordinate of this point is -8. Now draw another perpendicular line from this point on y-axis. It meets the y-axis at -4. So y coordinate of this point is -4. It means this point is 8 units away from the y-axis and is on the left hand side of the y-axis. This point is 4 units away from x-axis and it is below the x-axis. Consider this point now. Draw a perpendicular line from this point on the x-axis. It meets the x-axis at 3. So x coordinate of this point is 3. Now draw another perpendicular line from this point on y-axis. It meets the y-axis at -7. So y coordinate of this point is -7. It means this point is 3 units away from the y-axis and is on the right hand side of the y-axis. This point is 7 units away from x-axis and it is below the x-axis. Distance between two points on a plane. The distance d between 2 points x1, y1 and x2, y2 on a plane can be found by using the distance formula. Distance formula. Distance d between 2 points x1, y1 and x2, y2 on a plane is mathematically defined as d is equal to square root of x2 minus x1 whole squared minus y2 minus y1 whole squared. This formula is called as the distance formula. Example 1. Distance d between 2 points 3, 2 and 9, 8 on a plane is d is equal to square root of 9 minus 3 whole squared minus 8 minus 2 whole squared, which is equal to square root of 6 squared minus 4 squared, that is equal to square root of 36 minus 16, which is equal to square root of 20, and that's why d is equal to 4.47 units. So distance between the two given points is 4.47 units. Example 2. Distance d between 2 points negative 8, 2 and 8, negative 4 on a plane is d is equal to square root of 8 minus negative 8 whole squared minus negative 4 minus 2 whole squared, which is equal to 8 plus 8 whole squared minus negative 6 whole squared, and d is equal to square root of 256 minus 36, and d is equal to square root of 220, so d is equal to 14.8 units. Cartesian coordinate system in 3 dimensions. To describe the location of a point in 3 dimensions or in a space region, we take 3 axes. These axes are mutually perpendicular. These axes are called as x-axis, y-axis and z-axis. The common point where all the 3 axes meet is called as the origin. The positive and negative half axes seem to originate from this point. In 2 dimensions, we name x-axis as horizontal coordinate and y-axis as vertical coordinate. But in 3 dimensions, none of the coordinates is called horizontal or vertical coordinate. However, these coordinates are sometimes called as abscissa, ordinate and applicate respectively. Sometimes we take the 3 axes as x-axis runs out of and into the page, y-axis right left, and z-axis runs upwards and downwards as shown in the figure. However, it is convenient, just like in 2-dimensional coordinate system, to take x-axis right left along the page and y-axis upwards downwards in 3-dimensional coordinate system also. The third axis, z-axis, is taken out of and into the page as shown in the figure. While giving names to axes, one rule is very helpful. It is the right hand rule. It states, stretch the first or index finger, middle finger and the thumb of the right hand such that they are mutually perpendicular. Now, if the index finger is pointed towards positive x-axis, then middle finger points toward y-axis and the thumb is pointed toward z-axis. Each pair of axes defines a coordinate hyperplane, that is xy plane, yz plane and xz plane. The plane along the x-axis and the y-axis is xy hyperplane. The plane along the y-axis and the z-axis is yz hyperplane. And the plane along the x-axis and the z-axis is xz hyperplane. These planes have only a single common point, that is the origin. These planes divide the space in 8 three-dimensional infinite regions. These regions are called as the octants. Order of octants. If we take x-axis right left, y-axis upward downwards and z-axis out of and into the page or screen as shown in figure, then first, second, third and fourth octants lie in front of xy hyperplane in the same order as in the two-dimensional coordinate system. That is, starting from positive x-axis and moving counterclockwise, first we encounter with first octant, then second, then third, and finally fourth octant. Fifth, sixth, seventh and eighth octants lie on back of xy hyperplane in the same order as the front octants, that is, fifth behind first octant, sixth behind second octant, seventh behind third, and eighth behind fourth octant. But as said earlier, we can take x-axis out of and into the page or screen, y-axis right left along the page, and z-axis outwards downwards also as shown in figure. In this case, first, second, third and fourth octants lie above xy hyperplane and in counterclockwise order starting from positive x-axis if we look from top. Fifth, sixth, seventh and eighth octants lie below the xy hyperplane and in the same order as the first four octants. Sign convention. In first octant, x coordinate is positive, y coordinate is positive and z coordinate is also positive. In second octant, x coordinate is negative, y coordinate is positive and z coordinate is positive. In third octant, x coordinate is negative, y coordinate is negative and z coordinate is positive. In fourth octant, x coordinate is positive, y coordinate is negative, z coordinate is positive. In fifth octant, x coordinate is positive, y coordinate is positive and z coordinate is negative. In sixth octant, x coordinate is negative, y coordinate is positive and z coordinate is negative. In seventh octant, x coordinate is negative, y coordinate is negative and z coordinate is negative as well. In eighth octant, x coordinate is positive, y coordinate is negative and z coordinate is negative. How to remember? In x coordinate column, 1 positive, 2 negative, 2 positive, 2 negative, 1 positive. In y coordinate column, 2 positive, 2 negative, 2 positive, 2 negative. In z coordinate column, 4 positive and 4 negative signs. Distance between two points in three-dimensional space. To find the distance between two points in three-dimensional space, distance formula is used. Distance formula. The distance d between the 2 points x1, y1, z1 and x2, y2, z2 is given by the formula. This formula is similar to the formulas used in two-dimensional plane except the additional z coordinate. And this is all about this video. See you soon with the next video. Thank you for being with me. Stay happy. Goodbye.